Hi everyone. In this video, I am going to explain about Dijkstra's algorithm. This Dijkstra's algorithm is used to find the shortest path from the source vertex to all other remaining vertex for the given graph. Assume this is the given graph. For this given graph, so they'll tell the source vertex. From the source vertex, we need to find the shortest path to all other remaining vertices. Let us assume here A is the source vertex. So now if source vertex is A, we need to find from A to all other remaining vertices B, C, D. That means we need to find what is the shortest path from A to B, what is the shortest path from A to C, what is the shortest path from A to D, what is the shortest path from A to E. These things we need to find out. So only from one source, that means from single source to all other remaining vertices, we need to find the shortest distance. Okay. Hence, this problem is called as single source shortest path problem. That means from the single source, we need to find the shortest distance to all other. Hence, the problem is called single source shortest path problem. To solve this problem, we are using this Dijkstra's algorithm. Okay, let us solve this problem for this graph, assuming A as a source vertex. See, we can choose any vertex as source vertex, but here I am selecting as a source vertex as A. Okay, so again, this Dijkstra's algorithm uses greedy technique. Okay, so let us solve this problem. Let us find the shortest path from vertex A to all of the remaining vertices. Okay, again, I will use this table method. So, tree vertices, first column, second column, remaining vertices, illustration as usual. This is exactly same as Prim's algorithm. In Prim's algorithm, we used one principle, that is, whenever we are moving, see, this is the Prim's algorithm what we discussed in my previous video, that is in part 32. In that, always we moved from visited vertex to unvisited vertex. So here also we are using the same concept. Always we will move from visited vertex to unvisited vertex. Okay. So my tree vertex is my visited and the remaining vertex is unvisited. Okay. So now here, since it is using greedy approach, it solves one by one. That means from the source vertex, it finds the shortest nearest vertex. Then from that vertex, it finds the next nearest vertex. Like that, it is finding the shortest distance from the known vertex, that is visited vertex, to all the vertices one by one. Let us solve this one. So what we did, so we took what? First, any one vertex we selected randomly as a source vertex. Now here I am selecting source vertex A as my source vertex. That's what we said, source vertex as A. So A, I am writing A. So this A, whether I have traveled from any other vertex, no. So I am writing dash. From this vertex A to that same vertex, what is the distance? Obviously, it should be 0. So I am writing 0. This is my initial state. Now, that means I have selected one vertex as a source vertex. Now, this is my visited. Now, which are the remaining vertices among this given A, B, C, D, E? Which are the remaining vertices? B, C, D, E. So, I am writing this B. Now, B. B is whether directly connected to A? Yes. B is directly connected to A and it is at a distance from 4 from A. So, what I'll write? B of A, comma 4. That means from A, B is at a distance at 4. That B is at a distance 4 from A. That is from which vertex? Distance. Same as in Prim's algorithm. Similarly, C vertex. C vertex is directly connected to A. No. C is not directly connected to A. So what I will write? So we return dash comma infinity. So next D. Whether D is directly connected to A? Yes. D is at a distance 7 from A. So what I can write? Yes, A comma 7. That means from A, D is at a distance 7. So next, last vertex E. Whether E is directly connected to A? No, it is not directly connected to A. So what I will write? Dash comma infinity. Yes. So this is my remaining vertices. Now initially out of these 5 vertices, which one we have selected? A. So this is my illustration. See, meaning of this statement is we selected A as a source vertex. See, from source vertex A, B is at a distance 4, C is a distance not connected, D is at a distance 7, E is not connected. Okay, that's it. Now among these I need to find minimum. That means always whenever we are moving from one vertex to another vertex, that should be of the shortest distance. Now from A, which is the shortest distance? See, from A I can reach only B and D directly. I cannot reach C, I cannot E directly because there is no direct edge from A to C or A to E. So I can reach directly from A is either to B or D. So which is at the shortest distance? B or D? B is a distance 4, D is a distance 7. So which is minimum? 4, infinity, 7, infinity, which is minimum 4. So I am selecting this one. That means I decided to move from A to B. So that is the next vertex what I selected. So that is B. I traveled from A at a distance 4. So then remaining vertices I need to write as usual. That means what I selected now from A, I moved to where? B, and how much distance I traveled? 4. Okay, now see, now right now I moved from A to B. Now I am in B. Right now I am B. From B, C is directly connected. Yes, B to C there is a direct edge is there. So that is a distance 4. That means C from B it is what? 4. Correct? From C, B is a distance 4. But how we reached B? We reached B from A. We reached from B. To reach from A to B distance, how much distance we traveled? 4. So 4 plus 4. See here, since there is no direct edge from A to C, I came to A to B first, then 4, then B to C. So totally 4 plus 4, that 8, that only I am writing. So I can write directly 8, but in order to make you to understand, so I have written 4 plus 4. The meaning is from B, C is a distance 4. From B, C is a distance 4. But to reach B, I traveled 4 from A. That's this plus 4. Okay. So next, similarly, you check for D. Now, earlier, see why I have done this? Take 8. Previous value is infinity. Now the new value is 8. So whichever is the minimum, that I need to return. Again, this is the same concept what we use in the Prim's algorithm. So whichever is minimum, whether the current one or the previous one, whichever. See, this is the previous one. This is the current one. This is the current one. If this is what? If this is minimum, I have to take this one. Suppose the previous is minimum, I have to return this one. Here, the new one is minimum, I have taken this one. So now similarly for D. D earlier is 7. Now check. Now right now I'm B. Right now in B. I move from A to B. I moved from A to B. So from B to D is 1. So instead of reaching from A to D directly, so if you reach through B like this, my distance is 5. So which is lesser? 7 or this path 5. So this is shortest. So I'm applying this one. Now that means D is at a distance 1 from B. So what I'll write? B from B. D is a distance at 1. But to reach B, we need to travel 4, so plus 4. So since this 5 is minimum when compared to the previous 7, so I am updating the new one. Suppose previous only is minimum, I am returning this one. Okay. So now next E. E is not connected directly to B, so I am retaining the same thing, dash comma infinity. So now among these, which is minimum? 8, 5, infinity, which is minimum 5. So what I am doing, I am selecting D. That means I decided, first I decided A vertex from A to B. Now from B to D. That means first I moved from A to B. Then I decided I need to move from B to D. So this is B to D. This is what? Okay. So I will write. So D is, I reach D from where? From B. I travel total of distance 5. So now remaining vertex is C. Now you check C. Now C, from D it is 2. From D it is 2. But to reach D, 5. To reach D, 5. But from D it is 2. C is a distance 2. But to reach D, 5. So total is 7. But earlier is what? 8. So now see, through like this, 2, A to B, B to D and D to C. 4 plus 1 plus 2, 7. But To reach the previous one is, this is 8. Previous 8 and now it is 7. Which is minimum? 7 is minimum. So instead of reaching C from B, I decided now reaching C from D. That means from D. Okay. So C is at a distance what? 2 from D. So 2 plus, to reach D, how much would I travel? 5. To reach D, 5. Okay. So next E. E is at what distance from, now I'm reaching now I'm in D. See, right now I'm in D. Right now I'm in D. So D to E 5. That means E is at distance 5 from D. Okay. So E is at a distance what? From D 5. But to reach D, I already traveled 5. So this is 5. 5 plus 5. So 10, infinity is greater. This is lesser. I use this one only. That means now what I did. So first I reach from A to B. So then I reach from D. From where? D I reach from B. So I write D like this. So this is 1. This is what? Totally 5. This is what I have done. Okay, these are the remaining vertices. So now among these two, which is minimum? 7, 10. Which is minimum? 7. So I am selecting node C. So that is C is at a distance what? From D, 7. So remaining is E. See now, see the diagram. See whether you reach C. Okay, now what is remaining? E. Let's see, remaining is E, right? So E, if you reach like this, A to B to C to this one, 11. One path, 11. So okay, if you reach like this, 11. A to B to C to E is 11. If you reach like this, 12. If you reach like this, see 4 plus 1, 5. 5 plus 2, 7. 7 plus 3, this one, 10. If you reach 4 plus 1, 5. 5 plus 5 also 10. So that means right now I'm in C. Right now I'm in C. If you reach E from C or 3. 3 plus, but to see what? To see in it for 7. 7 plus 3, 10. So that's what I've done. But from D also it is same 10. From D also. That means from D it is 5. But to D, 5. 5 plus 5, 10. So earlier is 5 plus 5, 10. Suppose if I reach C. From C. From C what? From C it is 3 distance. From C. 3 distance. But to reach C, 7. So 7. So either you get new value or return the previous value. Both are same, 10 and 10. Okay. You can select whichever you want. Okay. So now, as of now, what I did. So A. So B. So D. So then see, this is what my decision right now. This is 4. This is 1. This is what? 2. Okay. This is what C is. Now this is the only one remaining. Since only one is remaining, no need of selecting, simply as it is, I need to take that one only. So I am reaching E from C by traveling a distance of 10. So nothing is remaining, dash. So I got A, B, C, D, E. So this is my, this 4, 1, 2. Now I reach E from where? From C. That means this one. So it is at a distance what? 3. It is the 3. Okay. So now this. Now I got C. I reach. See, from the table only you get everything. See, now I'll update from A to B. Okay. So A to B. Okay. Let us write this here only. Once again. A to B. What is the path? Directly I reach from A to B and I travel the distance, shortest distance what? A to B is 4. See here B. B I reached from A at a distance 4. So next A to C. Similarly I need to find A to D. Then A to E. What is the shortest path from A to C? C I reach C from where? D. Okay. C I reach from what? D. C I reach from D, but D I reach from what? B. B I reach from what? A. So this is the path from that means A to B to D to C. That means A to B to D to C. This is what? A to B to D to C. So distance is 7. So shortest path is 7. So this one, C7. Next, D. How I reach D? If you observe here, D I reached from where? B. Okay, D I reached from B. But B I reached from what? A. See, B I reached from A. So D, here, see, D our A to B to D. Distance is what? 5. So A to B to D, this is the shortest distance. A to B to D. So next, A to E. You can observe here only, illustration part. E I reach from C I reach from D I reach from B. So A, B, D, C, E. This is my shortest path. A to B to D to C to E. Shortest path is what? Totally 10. So this is my shortest distance. See, thus I found the shortest distance from the source vertex A to all of the remaining vertices. We found the shortest path and its shortest distance. So this is how Dijkstra's algorithm works. Now let us write algorithm for this. So before writing the algorithm, I'm using some of the variables. So that I'm defining. So this is the given graph, but this graph as it is not possible to give as an input to our program. So this graph I'm writing in terms of cost adjacency matrix. So the cost adjacency matrix for this graph is, see what is the distance from A to A? Always from vertex to the same vertex 0. A to B is 4. So A to B is 4. A to C no direct edge, so infinity. A to D is 7. A to E no direct edge, so infinity. Similarly, what? B to A is 4. B to B is 0. B to C is what? 4. B to D is how much? 1. B to E no direct edge. Similarly, C to A no direct edge, infinity. C to B 4. C to C 0. C to D 2. C to E 3. Similarly, D to A 7. D to B 1, D to C 2, D to D 0, D to E 5. Similarly, E to A no direct edge, infinity. E to B no direct edge, infinity. E to C 3, E to D 5, E to E 0. This is my cost adjacency matrix for this given graph. I'm using this one. And I'm using one more array called S. Okay, you can name it whatever you want, but I'm using this name A. Okay, so now this is my index. So this array gives the information about to which and all the vertex I find the shortest distance, which and all the vertex I not found. For that, for which vertex I find the shortest distance, that I make it 1. For which vertex not found, that I make it 0. See, for which vertex shortest distance found, that I'll make it as 1. If it is not found, that I'll make it as 0. This is the array. Okay, this array, this is my index 1, 2, 3, 4, 5. Generally, array index is 1, 2, 3, 4, 5 only. Since you have taken the vertex names A, B, C, D, I written like that. That means, what is the shortest distance from the source vertex to A, source vertex to B, source vertex to C, source vertex to D, source vertex to E, source vertex may be whatever. So for that, if I found a distance, I made it as enter as 1, that is a true. Otherwise, I will make it what? False. Okay, this is my for this one. Now I'm using one more array called distance. And this array gives us the information about what is the shortest distance from the source vertex to all the remaining vertices. Okay, so again, I take the index 1, 2, 3, 4, 5, but for your convenience, written vertex name also A, B, C, D. So what is the shortest distance from source vertex to A, source vertex to B, source vertex distance to C, source vertex, what is the shortest distance from source vertex to D, distance to E. So that this is the array gives us the information. So what I will do, initially I made it all are what? False. Initially I made it what? All are false. Then initially what I will do, whatever the cost adjacency matrix is there, that only I will copy. That I will trace and I will show you. So now initially I copied from the cost adjacency matrix to this one, source vertex. Here which one we have taken as a source vertex? A as a source vertex we have taken. So that will say V. Okay, now in general, see, somebody take A as a source vertex, somebody can take B, anything. So in general, it says small v. V indicates the source vertex. Okay, so this is the name I have given to this algorithm Dijkstra's. So given the source vertex is nothing but V. So we have taken source vertex in general. And then cost adjacency matrix for the given graph. So this is the cost adjacency matrix. So that is one term is the number of rows, number of columns. How many number of vertices are there in our graph? Okay, how many number of vertices are there? That many number of rows and that many number of columns. Okay, so this is 1 to n, the number of rows, number of columns. N indicates the number of vertices. So now what I have to do? Initially I made it as 0. For that, since it's a one-dimensional array, whenever we are doing any operation on any one-dimensional array, we have to use one for loop. So for that, I'm using for I is equal to from which vertex? From the first vertex to last vertex, n vertex. So what I did, 1 to n, I did what? S of I, what I made it? Initially I made what? All are 0. 0 means what? 0 means what? I did false. So I did false. That means initially I have not find the shortest distance to any of the nodes I not found. So I did all are 0 for this one. Next, distance matrix. Now, which one we have selected as a source vertex? We have selected vertex A as a source vertex. So from vertex A, what is the shortest distance to A? 0. From source vertex to B, 4. Source vertex to C, infinity. Source vertex to D, 7. Source vertex to E, infinity. This row I need to copy. For that, where to copy? To the distance of I. That is, distance of 1 should be what? 0. Distance of 2, 4. Distance of C, infinity. Distance of D, 7. This one to copy from where? So cost adjacency from the source vertex, comma I. Okay. So this is just for what? Initializing. So now this is, hope you people understood. Initially I is equal to 1. N is what? 5 actually. 5, 1 is less than or equal to 5, true comes inside. S of 1 is equal to 0. This is done. So then distance of 1. Distance of 1, you made what? Cost of V comma I. I will 1. V comma 1 is what? 0. This 0 I made it here. So next after that goes back. I becomes 2. 2 less than 5, true comes inside. S of 2, it would make 0. So then cost of V comma 2. Cost of V comma 2. This is C. This is 1, 2, 3, 4, 5. Cost of 2 is 4. That 4 I am assigned to distance of 2. So 4. So next I becomes 3. So cost of 3 comma I. Cost of, so V comma 3. That is infinity to distance of 3. So like that, first row I copied. Okay. This is my initial distance. Okay. So initially my distance. And we know what? Always shortest distance from vertex to itself is 0. So what I will do for distance of what? Source vertex to source vertex is 0. So I made distance of A to A, I made 0 once again. So then I made what? See, for that we need to find the shortest distance. Source vertex to source vertex we need to find no. So that means already found, assume. So S of V I made it as what? True. So what happens now in this case? S of this is 1 remaining or 0. This is 1, 2, 3 index. Okay. So now this is my initial setup. Now what we did, see exactly what we solved the problem, right? See here, this is the problem, first statement what we did. See, we simply selected what? We simply set one vertex. That's what the selected vertex is, source vertex. For that distance is 0. Distance is 0. For that I need to find the path. Okay. So then 0, 4, infinity, 7, infinity. Now you observe here. See, 0. See 0, 4, infinity, 7, infinity. 0, 4, infinity, 7, infinity. See 0, 4, infinity, 7, infinity. Same thing we got. Now what we did next time? Next time in the problem, from vertex A, that is from visited to unvisited, which is shortest. Among 4, infinity, 7, infinity. Among the unvisited, which is the minimum, that I selected this one. 4 is minimum. I selected. Now same thing I need to do. Now that means that you need to repeat, right? First time I selected, 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 selected. So I need to repeat. How many times? See, here 4 times I did. 1, 2, 3, 4 times. Because what? We need to find shorter distance to remaining vertices. That means -1. Because see, already we know for this one, from here, from 2 I need to find out. So what I can write? So I will write for, I will take one more variable called num. For num is what, from where to find out? From 2 vertices to find out. Because for this one I have to find out. From 2 I have to find. From num is what to what? And last vertex, what I have to do? So now I need to select what? One vertex. Okay. So here I selected B. Here I selected B. Always we selected B now. No, we don't know which one we select. Okay. So we need to choose in general some vertex that I'll take as an U. That's what visited V, unvisited U. So okay. So that I will write now. Okay. So choose one vertex in general, that is U. From where we need to choose? From among the vertices. From which vertices we need to select? From among the vertices that are not in S. That are not in S. Which are not in S? This is yes, yes. This is not, no, false. These are not in S. B, C, D, E. That means what? B, C, D, E are in the remaining vertices. B, C, D are in the remaining vertices. That is, that are not in S. Okay, such that what? Such that that distance to that one U should be what? Minimum. That's what we selected here. See, we selected one vertex among the unvisited vertex, which is minimum. Distance of that is minimum 4, infinity, 7, infinity, 4 is minimum. That we selected. So once I selected that, I made that vertex as what? S of U. I made it was true. So here, which is that we selected? In this case, problem B we selected. B selected. So S of B, I am making this as 1. S of B, I made it 1. Okay. So now I need to find out for B. Now I reach from A to B. Then I need to find out from B where I need to move. So I need to find the adjacent vertices. So because there may be more than one adjacent vertices for any vertex. So what I have to do? So again, I will use one more for here. For each W adjacent to what? U with what? S of W is equal to false. That means that should be false. Okay. So for that, what I have to do? Now I have to check whether the previous value is what? Whether the previous value is minimum, this value is minimum. I have to check. If the previous value is greater than the new value, a new value only I need to consider. So that I need to write the equation. What is that? So here the new value is what? W. Okay. So now I need to check if distance of W greater than distance of U plus cost of reaching. See, that what we written. See, cost of reaching from that vertex to that is plus we written everywhere. Okay, that we have to write. Cost of what? U comma W. Then what? That means if the previous value is greater than the new value only I have taken as the shortest distance. So if this is true, distance of W is equal to distance of U plus cost of U comma W. That's it, the algorithm. End if. So then you do this end for. So then again this outer for I need to end for. So then finally I need to end the algorithm, that is Dijkstra. So okay, this is the algorithm. Okay, so now I will trace this for you. See, hope up to this statement you understood. We started. Now this is my u. Now I choose the u from among the vertices that are not in S, not in BCD. Among the BCD, minimum is 4. So this is what in the table 4 we selected. So that I made it as S of u is equal to true. That I made true. So this is my u. Now u is my b. For b, which are the adjacent vertices? See, for b, which are the adjacent vertices? B, A, C, and D. For B, which are the adjacent vertices? A, C, and D. That, what is the condition? S of W should be false. So S of A is false, S of A is true. Now A I am not considering. So for B, C, and D, because both S of C is false, S of D is false. So now B may be, that means W. W may be this one or this one. Now for assume, now right now my W is, for example, see, this is for tracing. This is for tracing. Now U is my B, W is my what? C. Now you check distance of W. W is what? C. Distance of C is what? Distance of C is infinity. Infinity greater than. Infinity greater than. Distance of U. U is B. Distance of B. Distance of B is 4. 4 plus cost of u comma w. Cost of u comma w. U is B, W C. Cost of B to C. See, cost of B to C is what? 4. So 4 plus 4. Infinity greater than 4. 4 plus 4, 8. True. Condition is true. Same 8 I am assigning to distance of the 8. Distance of W. Distance of W means what? Distance of C. Distance of C earlier is what? Infinity. Infinity. That I am changing to what? 8. I did 8. Okay. So this is over. Next comes. Next W is got what? Now D. Because see, for this one, for this graph, one is C adjacent, another one is D. So next is D. W is equal to D. Now for that again I am checking the same condition. Distance of W, distance of D. Distance of D is what? 7. 7 greater than what? Distance of U. U is B. Distance of B is 4. So distance of B is 4 plus cost of U comma W, that is B to D. Cost of B to D is what? 1. 4. 7 greater than 5. True. 7 is greater than 5. True comes inside the same 5 I am assigning as distance of W. Distance of D is now updating as 5. So earlier is not 7, 5. So this is what we updated in the second column. See here. See, earlier it is infinity. Now it made it as 8. See, infinity 8. See, infinity 8. So then 7 to 5. See, 7 to 5 we did. This is what updated. This is what the statement. So now after that what happens? So all the adjacent vertices are over, goes out of the for loop, goes to the num. Num becomes now 3. 3 less than 5 true. Come inside. Now again it choose U from among the vertices that are not in S. Which are not in S now? C, D, E are not in S. That means C. Only C, D are in the remaining vertices. C, D, E. Among these, which is minimum? 8, 5, infinity. 5 is minimum. So I am selecting D. This is my U now. Now this is my U. Which is 1? D is my U. Okay. So now my U is what? U is what? D. Now for D, which are the adjacent vertices? For D are adjacent. See, A, B, C, E all are adjacent. But already which are already to A, B. So A, B are not taking. So C and D. So W may be C, W may be E. Okay. So that I need to find out. Okay, that one. Okay. Now again, suppose considering now W is equal to C. W is equal to C. So W is equal to C. Now again same condition. Distance of W. Distance of C. Distance of C is what? 0. 0 greater than distance of C. So distance of C is what? 8. 8. I checked in S distance. Distance of C is 8 greater than distance of U. Distance of U is D. See, U is D. Distance of D is 5 plus cost of u comma w, that is d comma c. D comma c is 2. 8 greater than 7, true. This condition true comes inside. 7 only I am assigning it as distance of W. W is what? C. Distance of C. Now distance of C, now earlier is 8, now it is 7. See, that's what we updated here in the problem. See, earlier it was 8. See, 8. C distance. Now it was 7. We updated 7. See, that's what we did here now. So from 8, I updated as a 7. So now W is equal to C is over. Now my W is what? E. W is what? Now my E. Now same thing. Distance of W, distance of E. Distance of E is what? Infinity greater than distance of U. Distance of U is what? Distance of D is 5. 5 plus distance of U comma W, that is D comma E. D comma E is 5. 5 plus 5, 10. Infinity greater than 10, true, comes inside. 10 is assigned to distance. So that is distance of W, that is distance of E. That means earlier is infinity, now it becomes 10. See, same thing what we did here. See, infinity, earlier is infinity, now we replace by 10. Okay, so this is how it works. So like that, it will check all the vertices and finally we will get this vertex. Okay, so let us check. Okay, now I did this one. Now again goes here. Now num is equal to 4. 4 less than or equal to 10, true, comes inside. See, I forgotten this one. This one I made it 1. See, as soon as I selected U, is of U, I made it true. So now choose U from among the vertices that are not in S. Which are not in S? Yes, C and D. See, now see, only C and D are there. Among C and D, which are minimum? 7. So C I selected. So that means my new U is C. Okay, now U is my C. U is my C. U is C. U is C. So now S of U I made it as true. So I made it as a true. S of U I made it as true. So now check. For E W adjacent to U is S of W is equal to false. Without S of W is false, E only. So for C is adjacent. Yes, for C is adjacent. So I am taking W is equal to E. W is equal to E. So now again the same formula. Distance of W. Distance of E. Distance of E is what? Distance of E is 10. Greater than distance of U, distance of C. Distance of C is how much? Distance of C is 7 plus cost of U comma W, that means C comma E. C comma E is what? 3. 10 greater than 10. 7 plus 3. See, the same thing we did here. See, 5 plus 5, 10 greater than 3, 7 plus 3, 3 plus 7. Checked. Same thing we did here. Okay. Now, false comes out, I'm returning the same thing. Comes out, I'm not updating anything, comes out. Next, 5. 5 less than equal to 5, false. Now, this is my shortest distance, 0, 4, 7, 5, 10. Okay, same thing we got at the end of the, okay, you see the problem here. See, 4, 7, 5, 10. See, 4, where is this? Here. 4, 7, 5, 10. 4, 7, 5, 10. 4, 7, 5, 10. Same thing you got. Okay. This is how Dijkstra's algorithm works. Hope you people understood. So this is the algorithm for that. If you have any questions, okay, please write it in the comments. Thank you. Thanks for watching.